Hello dear students, welcome you all for transmission and distribution class. So continue with the performance of transmission line. We have seen all the types of transmission lines: short transmission line, medium transmission line, and long transmission line. In medium transmission line, we are seeing end condenser, nominal T, nominal phi method. So now we will see a generalized circuit constants of a transmission line. We need to write the generalized form, that is we are going to write the sending end voltage and sending end current in terms of receiving end current and receiving end voltage. This is what the our aim. So for any kind of network we need to write. So I am writing here, you can just see sending end voltage Vs is equal to A VR plus BIR, sending end current Is is equal to C VR plus DIR, where VR and IR are the receiving end voltage and receiving end current respectively. Vs, Is we are knowing sending end voltage and receiving sending end current. Okay. Now you can see here all these vectors are only by ABCD vectors are complex numbers, is known as the generalized circuit constants, or we are calling it as ABCD parameters. So in the first equation Vs AVR plus BIR. Now what exactly this one? See here, each ABCD will have its own units. Why means your Vs is in terms of volts, is it? Then VR is in volts only, and then B is IR is in amps. Now the whole equation gives us the unit as volts, means A into VR. VR is in volts, so A is having no units there. Okay. Then B is multiplying to IR. IR is in amps, but we want it in volts, means it is nothing but your impedance. Ohms is the unit for the B. Coming to I, we are having CVR into DIR. VR is in volt, means we want current here. V by impedance must be there, so it is admittance. C is admittance and D is unitless constant. So or these are commonly complex numbers. A and D are the dimensionless, and B and C are the ohms and Siemens, that is impedance and admittances. For a given transmission line, A is equal to D, and for a given transmission line, this is the so proved that AD minus BC equal to 1. Or if you are finding your ABCD parameters whether right or wrong, if your AD minus BC is coming 1, then you can tell that your ABCD parameters are correct. So we can write the constants as Vs is equal to AVR plus BIR, Is is equal to CVR by DIR. Now we will see for the short transmission line. So I will recall you the equations of the short transmission line. We are knowing that Vs is equal to VR plus IRZ, is it? And Is is equal to IR. You can recall, otherwise if you are not getting, you just see this figure 10.23. Vs, Is flows, and Z is there. IR is same as Is. VR is having a voltage across the load. Then Vs is equal to Is Z into VR. So these equations you have to compare with the this equation 1 and 2, that is Vs and Is equations. You can see here in Vs is equal to VR plus IR Z is the equation in short transmission line. Our generalized line is Vs is equal to AVR plus BIR. Here VR is multiplied by 1, means A is 1, and IR is multiplied by Z, means B is Z. Okay, I can write here for comparing the first equation, A as 1 and B as Z. Coming to the second equation, Is is equal to CVR plus DIR. But in short transmission line, I am having only Is is equal to IR. So my VR is multiplied with C. C is 0 and D is 1. So I can write that value of C is 0 and D is 1. If your if A is 1 and D is 1 you are getting. So as your rule it says A is equal to D is same. Now you can get the AD minus BC. You will get 1 into 1. A and D are 1. B is Z. C is 0. So 1 minus 0 is 1. So this is proved now. Okay. Now medium transmission line we will see. The equations we are knowing: Vs is equal to V1 plus Is Z by 2, and Ic is equal to Is minus IR. Or we can write our Is is equal to the equations as IR plus YVR plus Y into IR Z by 2, or I can write it YVR plus IR into 1 plus YZ by 2. This is regarding my equation for Is. So I got now Vs as VR plus IRZ by 2 plus ISZ by 2, or I can take the VR and IR terms together. So I can write Vs is equal to 1 plus Yz by 2 VR plus Z plus Yz by 4 into IR. You can just refer the equations 6 and 7 here. 6 is the equation for IS and 7 is the equation for VS. Compare it with VS IS equation as number 1 and 2. That is VS is equal to VR AVR plus BIR. IS is equal to CVR plus DIR. Okay. If you compare that one, you will get A is equal to D same as 1 plus YZ by 2. You can see it is multiplied with IR, that is 1 plus YZ by 2. Here multiplied with VR in the VS equation 1 plus YZ by 2. So A is equal to D same as 1 plus YZ by 2. And B is, you can see, multiplied by VR is B in case of VS equation. What is this multiplied? Here we B you can see here it is B is multiplied to IR, no, so that is Z plus YZ by YZ square by 4, or if you take Z as common, Z into 1 plus YZ by 4 as the B. C is Y here. C what is Y? And the C is multiplied to VR in case of IS equation. So here IS equation Y VR plus IR Y 1 plus YZ by 2. Here Y is multiplied to VR means I can tell that C is nothing but Y. So if you find the AD minus BC, you will get 1. You can do by your own. Coming to the next nominal phi method here. Nominal phi method equations are directly I am going to give you. After solving this one, you will get IS is equal to IR into 1 plus YZ by 2 and VR into Y into 1 plus YZ by 2. That is the 11th equation you can see. And you can see here the in 10th equation Vs is equal to VR into 1 plus YZ by 2 plus IRZ. So these two equations we will get. Okay. Once we will get these two equations, we need to compare it with the main equation, that is Vs is equal to AVR plus BIR, IS is equal to CVR plus DIR. So if you are comparing those, you will get A is equal to D as 1 plus YZ by 2. Here B is equal to Z and C is equal to Y into 1 plus YZ by 4. So you will get the equations for AD minus BC as 1 only. You can try by your own. Next is long transmission line. That is also equations we are knowing. Vs is equal to VR cos hyperbolic of square root of YZ plus IR into square root of Z by Y into sin hyperbolic of square root of YZ, and IS is equal to VR into square root of Y by Z sin hyperbolic of square root of YZ plus IR into cos hyperbolic of square root of YZ. So it is very simple now. Direct things are there. Compare with the 1 and 2 equation, that is Vs and IS equations. So I can write here A is equal to D as cos hyperbolic of square root of YZ. B is square root of Z by Y into sin hyperbolic of square root YZ, and C is the square root of YZ into sin hyperbolic of YZ. So if you find AD minus BC, you will get the 1. So this is regarding the ABCD parameters of the different lines. Starting from the short transmission line, medium, mean medium, nominal phi and nominal t method, and the long transmission line method you are seen. So very simple. What you have to write the actual equations of Vs and ISs in the what mode you are having, whether it is short, medium or long. Then compare that with the Vs and Is equations. So you can get the ABCD parameters. Okay. So this is what is ABCD parameters. The problems are left in this unit. So we will see it in the next class. We will see one type of problem in each case. So we can get the things directly. So here very simple thing is we can express the sending end voltage and sending end current in terms of receiving end voltage and receiving end current. Okay, so ABCD are the 4 parameters. A and D are the dimensionless unit, B is the impedance, and C is the admittance. Okay, so if you find any difficulties, you can ask me. In the next class we will see some problems on this. So by that we can finish the module, 4th module, that is the in your class, the module 3 going to finish us. Okay, thank you.